Hello there, I'm Thomas Hatsios, German American pilot flying the Boeing 787-900 tonight's flight from Zurich International Airport. We're going to be flying Zurich, Switzerland, Germany, then coming back to the Zurich International Airport. Runway 1449, let's localize and landing. So now I'm in the cockpit for the pre-takeoff preparation of the quality wings Boeing 787-900 Microsoft Flight Simulator X. I'm going to start showing the cockpit instruments, the displays, and the functions of the Boeing 787-900 jet aircraft. I'm going to start with the primary flight display that displays the airspeed indicated, the airspeed selected from the autopilot flight director system panel, the ground speed, the radio altitude above the ground level, the barometric altitude above the sea level, the target altitude selected from the autopilot flight director system panel, the barometric pressure of the outside atmosphere, the vertical rate of climb descent of the aircraft in tens, hundreds, and thousands of feet per minute. All the stages of the trigonometric calculus in degrees can climb descent. We have also the artificial horizon with the altitude indicator, the pitch ladder in degrees, and the bank angle in degrees, the ILS localizer, the onboard antennas of the ILS localizer that receive the radio frequencies transmitted from the threshold runways. So we can align with the localizer, the horizontal localizer, and vertical glide slope of the aircraft. You can see in the primary flight display the horizontal localizer and the vertical glide slope. We align with the magnetic North Pole heading of 136 for this runway, the runway 14 in Zurich International Airport. So I'm going to show you how to tune the frequency and use the ILS localizer both for takeoff and for landing. We have also the flight director crossbus for manual guidance of the aircraft and the autopilot crossbus for automatic guidance of the aircraft, the angle of attack of the aircraft as it flies, and the flight mode done at 0 with the autopilot and the autothrottle. Later on vertical navigation modes. We have also the navigation. We have the HSI that displays the horizontal situation indicator. You can see the integrated display of the flight plan. We have the navigation display that displays the magnetic North Pole heading and the geographic North Pole heading and the magnetic variation depending on where we are in the world. We have the terrain map with the airports, the waypoints, the board stations, the ADFs. So you can see the airports display with the 4-letter code name. Also we have the runways, the taxiways we use for takeoff and for landing, the runways heading and the runway length. Also the taxiways, you can look around. And we have the navigation aids, the ADFs and DPs, board station, and the waypoints with horizontal vertical navigation fixes the aircraft can fly through. We're gonna have to select from the flight management computer in a couple of minutes. I will show you how to use the flight management computer to create a flight plan or a flight path or a route for using with this navigation display and how you can interact with the autopilot flight director system panel. You can connect the LNAV and the VNAV navigation, which will use the flight plan you have created to follow as a flight path. So you can see, so I'm gonna show you also the autopilot flight director system panel over here. The ACAS that displays the engine indication, the crew alerts, system displays. I'm gonna show you also the flight controls over here. So you can see we can climb and we can descend, we can make turns in flight, left and right, as you can see. You can use also the rudder pedals. I'm gonna show you also the thrust levers over here. How I use the thrust levers to increase the degrees the thrust commanded by the engines, by the FAREX. The FAREX are the full authority digital electronic control computer, one installed per engine gearbox, dual channel redundancy, one channel phase, the other takes over control modes and displays all the engine data using the upper and lower ACAS. As the indication for the system display, like the N1, which is the low speed starters, have low pressure compressor and tube under the turbofan, which is the engine, the exhaust gas temperature per engine. The N2, which is the high speed starters, have high pressure compressor and tube under the turbofan to the engine, the fuel flow per engine per hour, 1000 kilograms, for the first roll temperature quantity, and the vibration of the N2 stage of the engine over here. So you can see what the ACAS, the engine's indication, the N1, low speed starters have low pressure compressor into one of the turbofan temperature engine, exhaust gas temperature engine, N2, which is the high speed starters have high pressure compressor and turbine with the turbofan tubular engine, the left and the right, fuel flow per 1,000 kilograms, 1,000 pounds oil per engine per hour, oil pressure, oil temperature, oil quantity, and the vibration of the N2 stage of the engine. So we have also here the takeoff limit and the green, red, yellow limits for the engine to not exceed. We have also the outflow valves for the cabin pressurization system that receive bleed air from the engines, pressurizer from the engines, which is used to pressurize the cabin. You can see cabin altitude right now, 1,400 feet around altitude, the rate of climb descent of the aircraft, the differential pressure. So the differential pressure will go up to 7.8 or 8 psi, and maximum cruise altitude like 40 or 45,000 feet, and the cabin altitude will go to like 6, 7 or 8,000 feet. So you can see also the landing altitude, the outflow valves position over here, open and close. So I will talk to you more about these systems, about the engines later. So we have also here the primary flight display that I was telling you. So you can see in the primary flight display we have the airspeed over here indicated, the airspeed tape, as you see in the original aircraft, all actions, all modes. So we have over here the airspeed indicated, the airspeed selected from the autopilot flight director system panel displayed with purple, just like in the autopilot panel. Here you see 200, 360 heading right now selected in 10,000 feet, because this is the autopilot engage and disengage switch, the flight director, auto throttle left and right. So this is the airspeed guidance. You select the airspeed in nautical miles per hour or Mach, and you have LNAV, VNAV, flight level change, climb continuous, auto throttle, heading. Also here, autopilot disengage, the vertical rate of climb descent, altitude over here select. So we have 200 knots, 360 heading, and 10,000 altitude. You can see here we have 200 knots selected for the airspeed here, and 10,000 displayed in the primary flight display, which is all the air data of the aircraft. And also the heading here in the SSI is 360 degrees. So you will see here in a couple of minutes the rest of the air data. So we have the airspeed tape, the airspeed indicated right now, 30 knots. The radio altitude above the ground right now, where it shows -2. The vertical rate of climb descent of the aircraft intends hundreds of thousands of feet per minute. You see this needle moves up when we climb and moves down when we descend the aircraft. You see how many hundreds or thousands of feet, like 500, 1,000, 1,500, 2,000 feet climb or descent. Also you can see the barometric altitude above the sea level, 1,430 feet right now. Over here with this barometric pressure setting of 29.92 inches of mercury, and the minimums radio 200. So this is the barometric setting right now. The baro set over here from the FS panel, we can set from here inches of mercury or hectopascal, and also starter. So right now we have 29.92 inches of mercury radio minimums, the map, the range. Also you can fix the display here, the plan, the other modes, and the range of the map. Right now is 80 nautical miles. You see 80 nautical miles, the range here. So you see range here, magnetic. And also we have weather radar, traffic and terrain on the display. You have also accept, cancel, reject some warnings over here. We have the systems of the aircraft will be displayed later, the CDU, the info, the checklist, the communication, navigation display, the engines. Right now we display only the engine. Later you will see the rest of the systems of the aircraft, like the ones we have, the electrical, the hydraulic, the fuel system over here, as you can see, will be displayed in the displays over here. The pressurization, the bleeder pressurizer, also fuel engines. So you will see all the systems will be displayed here in a digital format like in the original aircraft. So you can see also the navigation display over here. So we have also the altitude indicator with the pitch ladder decrease. You can see 2.5, 5 7.5, 10, 12.5, 15, 17.5, 20 degrees for pitch up or pitch down as we fly the pitch attitude of the aircraft. And also the bank angle over here when we make turns, left or right turns, you will see how steep turns in degrees. Also we have the flight mode annunciator over here. We have the auto throttle in takeoff go around mode right now. You can see also the autopilot. So we have also the ADS over here, the receiver of the ADS, some other the circle over here. So we have also the navigation display. You can see the terrain with red, green, yellow indications. Over here the terrain map, also the elevation of the aircraft above the ground level when we're going to be flying. You can see the triangle displayed, and you can see also 10,000 feet here, like in the primary flight display. Also in the autopilot is the altitude we have selected to fly the aircraft. It will be displayed here. If we set higher altitude, so you will see the terrain also. When you fly and you have some mountains, you're gonna see them. So in the navigation display, also the outside the aircraft system, the navigation display, you can see the terrain and weather effects from the weather radar. You can see the terrain with the red, green, and yellow. Indications with blue, the lakes, the rivers, the sea. Also in a horizontal and vertical profile, you can fly the aircraft close to terrain and you see the terrain below you or in front of you. Depending on the distance, it will change color, like yellow, green, or red. And also we can see other aircraft fly around one aircraft using the transponder. This being a DC transmitter receiver that transmits our frequency, radio frequency to other aircraft and the air traffic control. And receives from the other aircraft. You can calculate using the computer the other aircraft position, the distance from our aircraft. Also you can calculate the altitude difference from our aircraft, if they are higher or below, how many hundreds of thousands of feet higher or below they are. Also you can calculate the velocity closing in between our aircraft and the other aircraft. It will give us a warning if we have an incoming collision. You can calculate the heading between our aircraft and the other aircraft. If we have an incoming collision, it will give us the warning from the TICA system, traffic collision advisory system. So it will be displayed the TICA system. You can see the diamond shape of the other aircraft displayed in the navigation display. So we have a few more things to see over here. You can see also, as I told you, I'm gonna show you the flight management computer over here, how to create a flight plan, the mouse pad we're gonna use, the thrust levers, some other functions over here we have for the aircraft. So you're gonna see right now, maybe I'm gonna start showing you about the flight controls, how to control the aircraft's flight controls over here, as you can see. So we can climb and we can descend, we can make turns to the left, turns to the right. So I use the side stick, the Lszh Extreme 3D, which is identical to the Airbus side stick, as you can see. Also the rudder pedals, you can see the rudder pedals. So I will start showing you what all these things do to control the aircraft, the Boeing 787-900. So I'll start showing you all the views of the aircraft, and also from the outside I will talk to you about Newton's physics, aeronautical and aerospace engineering, and derive some principles we need to know about aerodynamics, the Bernoulli theory of fluids, Newton's physics, and we need to know for the air transfer pilot license and for the commercial pilot license. So you can see here the outside view of the aircraft. So you can see the view here. You can see the wings of the aircraft hold the aircraft weight as the aircraft flies, the surface area of the wings, so the weight is divided over the surface area. We have the thrust from the engines, the jet propulsion, so we can move just the engines, we can move the aircraft forward from the exhaust jet blast from the engines, from the cones. Also, you can see we have the compressors, the low and high pressure compressors, the turbine of the engines, and also the front fans. So these vectors are the thrust from the engine, the left and right wing. We have also in the wings, we have the mineral dynamic chord position over here. The Mach, which is 23% for this aircraft, is where the maximum aerodynamic lift will occur in the forward wings. It's also the position where the stall begins, the airflow becomes detached from the top surface of the wings all the way back, and the aircraft might gonna fall if we don't follow the stall avoidance maneuver. So we need to monitor all the time here where is the primary flight display. You see the airspeed indicated over here. We have the stall speed below here with the yellow and red when we fly, and also the angle of attack. So we need to add thrust and pitch down the aircraft when we have stalled. So it stalls from the top surface. Over here with the mineral dynamic chord also is where the center of pressure is moving forward and aft when we fly. Also, we have the center of gravity of the aircraft transverses through vertically. Here is the yawing axis, also the center of gravity. So the yawing axis over here to yaw the aircraft using the rudder to make a left or right turn. As you can see, this is the yawing axis, and also you can use in the ground the nose wheel steering over here to control the aircraft using a deflection of 76 degrees approximately left and right using the nose wheel steering. And you have both the rudder and the nose wheel. So in the ground until 45 knots, and then it decreases linearly, or it decreases to like 7.6 degrees above 45 knots from 76 degrees, the deflection of the nose wheel, because you have the rudder aerodynamically effective above 45 knots. So it combines together. Then at above 70 or 80 knots, you have only the rudder, and the nose wheel steering disconnects, so it goes to zero deflection above 80 knots in takeoff or in landing. So you have only the rudder for steering the aircraft left and right. So you use the nose wheel steering and the rudder, both deflections over here, using the rudder pedals, which is the yawing control of the aircraft, to make left and right yawing turns over here, as you can see. So you make left and right like this. I have the control in the side stick of the rudder pedals. We have also the tiller here, as I told you, for the nose wheel steering. We can use either one, rudder pedals for deflecting the nose wheel of the aircraft, or the rudder. So we have also here, also in the rudder pedals, you have the toe brakes. You can press the toe brakes and stop the aircraft from moving. We have also here the control column. So we have also, I keep telling you about, we have the vertical axis, which is the yawing axis, the rudder pedals, and the nose wheel steering. We have also the wingtip. From wingtip, this axis is the pitch axis of the aircraft as it flies. So the pitch axis is for climb and descent. In the Airbus is the side stick up or down like this. You move the elevator, same like in the Boeing. You move the yoke to move the elevator up and down. So it's the same principle. You either move the side stick up or down, or you move the yoke for climb and for descent like this, as you can see here. So you climb and you can descend like this. You move the elevator or the yoke. In the Boeing, it moves the elevator up and down, or in the Airbus, the side stick is doing the same thing. Also, we have one more axis to show you here. So we have the longitudinal axis from nose to tail over here. So this is the roll axis. So in the Airbus, you make left and right side stick deflections. You use the ailerons and the spoilers, the roll spoilers. Also in the Boeing, you have also the flaperons. In the Boeing, you have all the controls, ailerons, spoilers, and flaperons, as you can see, to make left and right turns. Also with the speed brakes extended. So the in the Boeing, you have the control wheel instead of the side stick, so you use the control wheel to make left and right turns, which is the roll axis of the aircraft. So this is all longitudinal axis of control and stability of the aircraft as it flies. You can see the side stick deflection is proportional to the yoke deflection. Also, I forgot to mention from the aerodynamics and the Bernoulli theory of fluids over here. You can see the bottom of surface of the wings is more flat. Also, as we accelerate for takeoff to like 140 knots, like 250, 270 kilometers an hour, we have the flaps extended, and also we take an angle of attack that is mainly positive in flight. So using the Bernoulli theory of fluids, we have lower airspeed of the airflow below the wings, which creates higher air pressure, which pressurizes the aircraft weight and wings up into the air. Also, you can see, so we have differential pressure between the bottom and the top surface. So you can see the top surface, the wings have higher curvature, so the airflow is moving much faster above the wings. That creates lower air pressure, which sucks the weight and wings up into the air. So this is the main principle of the aerodynamics we need to know about flying the aircraft. Also the flight controls, you can see the side stick deflection is proportional to the yoke. Also we have the horizontal trim stabilizer over here. You can trim the horizontal tail of the aircraft, pitch up or pitch down like this. So you trim the horizontal tail, I'm gonna show you. You can see, so this switch is for trimming horizontal tail as you fly, the elevator, or the whole surface in some other aircraft. So you can see elevator trim. So you see elevator trim, left click down, right click, as you can see here, elevator trim, right click down, left click, so right click. So this way you pitch the nose of the aircraft up as you fly, and this way you pitch the nose down, so you balance the aircraft aerodynamically using the horizontal tails elevator for doing that. So you trim the elevator up and you trim the elevator down, you pitch the nose up and you pitch the nose down, it's the same thing. So you have also the head-up declutter over here, the head display. We have the autopilot disconnect switch over here. As you can see, autopilot disengaged. The flaps limit speeds over here. So we have, as you can see, the control wheel to control the aircraft. We have also the control column, the rudder pedal. So this is all flight controls. Also we have, as you can see here, the alternate pitch stream over here. So we have the flight control computers over here. So this is a flight control fly-by-wire aircraft. So you have alternate pitch stream over here. You pitch the nose up as you fly, nose up and nose down this way. So you trim the elevator up and you trim the elevator down. So you do other thing as you like it, as you feel more comfortable actually as you fly. Also the parking brakes here, we have the switch, and we have the stabilizer cutoff switch over here. So this is for all Boeing, you can see stabilizer cutoff, left L2 and R2. So this is for all Boeing 737, 747, 757, 767, 777 and Boeing 787. You move from normal to cutoff and you disconnect the auto trim function from the autopilot and flight director system panel if you have a failure. So this is a fly-by-wire aircraft. It has the flight control computers, primary flight control computers, auto, as you can see, position. So the flight control computers, flight control surfaces over here. So if you have a failure of the hydraulics that affects either the left or right horizontal stabilizer over here, you move from normal to cutoff because you have a malfunction of the auto trim system. So you lose the automatic trimming from the autopilot for the flight director system panel. The flight control computers actually that commanded the motion of the autopilot, and now the flight management computer. So you have only the manual trim switch, because we have the normal, the alternate, and the direct mode. So this is the normal, which is also manual for this function for the horizontal tail trim. And you have also the alternate pitch trim over here all the time. As you can see, alternate pitch trim elevator moves up and moves down. So you can see how many degrees you can pitch up and pitch down the elevator, the stabilizer, and the rudder, and the flaps position also. So we can see here, we can climb, we can descend using the elevator, and we can also trim, use the horizontal trim stabilizer. So this is fly-by-wire aircraft, as I'm telling you. Deflection in the ground is direct, like in the Airbus. So you have normal, alternate, and direct modes. If you have failure, you have direct also. So primary flight control computers in the auto position. You have the normal, the alternate over here, normal, alternate, and direct flight control computers channels. So it's a flight control computer channel, the alternate channel over here for the horizontal trim, and the manual, the normal trim over here, as you can see. So you can use the other one channel of the flight control computers. So in flight, using the flight control computers, the deflection of the flight controls is proportional, I believe, to the G loads, like in the Airbus aircraft. You make G turns, like 2.5 left and right G turns, and you climb and descend, and like 1.5 or minus half G turns for climb and descend. So it has a G load limiter for deflecting the flight controls proportionally. So it's pretty much the same thing. So you can see, I'm gonna show you a couple more things about the flight controls here. So we have a couple more things to see. I will show you this view of the flight controls. So you see how we deflect, the side stick deflection, and is proportional to the yoke deflection. The captain and the first officer are moving together, they're interconnected, unless we have a failure. For the Boeing aircraft, and not like in the Airbus, you have the side stick priority button and you can use either side. All flight controls and the rudder pedals. So we have also the outside view again. So I'm gonna show you this view now of the flight controls, and I will continue with the rest of the systems of the Boeing 787. So stay with me until the end part of the video. You will see the complete flight of the aircraft. You're gonna see me flying the aircraft manually from takeoff, climb, cruise, descent, approach, and landing. So you can see here so you can see this view of the flight controls. I hope you like, and also you can see the screen also better or clear view. So we climb, we descend. You can see the side stick also I'm using. It's identical to the Airbus. Also the thrust. Over here we have the thrust control. So we move the thrust levers. This switch here. So we move the thrust over here, forward and off. So we have all flight controls like this. You can see again left and right side both move together, side stick deflection proportional to the yoke, climb, descend, make turns to the left, make turns the roll axis, left and right, and the pitch axis, climb the descent, the elevator. So you have the ailerons and the spoilers and the flaperons like this, the rudder, the vertical stabilizer, and the rudder pedals. So we have all flight controls, also the horizontal trim stabilizer over here, the engine. So this is all flight controls working together, as you can see. So you can climb, descend, make turns, rudder pedals. So make turns to the left and right, ailerons, spoilers, flaps, flaperons. Climb and descend. So this is all flight controls. So I will go for the rest of the systems of the Boeing 787-900Z aircraft. So I'm gonna start now showing you the flight. I'm gonna show you the flaps and the slats, the speed brakes, also a couple of secondary flight controls I forgot to show you. Now we'll talk to you about the flight management computer. So we can see here so I will talk to you about the flight management computer. I will input all the data of the aircraft for this flight first. So I will input the data of this aircraft for this flight, the takeoff gross weight, that includes the empty weight plus the passenger plus the cargo plus the fuel on board, where the fuel is stored in the left and the right wing tank. In the center tank, the flight management computer is gonna calculate automatically the center of gravity of the aircraft from takeoff, climb, cruise, descent, approach, and landing. As we fly, the aircraft burns fuel, so the center of gravity is shifted and is recalculated. Also, we have as I told you, the center of gravity and the mean aerodynamic chord position, the Mach, which is 33% of the mean aerodynamic chord with the maximum aerodynamic lift occurs in the forward wings and the stall. So the flight management computer calculates all these things for the air data. Also, computers like the stall speed and the angle of attack of stall. So you can see also we're gonna use 15 degrees of flaps for takeoff. We're gonna have a horizontal trim stabilizer of 4.35 degrees. Also we have the auto train, the automatic training of the horizontal stabilizer as we fly for takeoff, climb, cruises, and approach and landing. So we're gonna use the runway 104 in Zurich International Airport, Lszh in Switzerland, runway 14. We're gonna have the runway length, the runway slope, the wind direction and speed, the barometric pressure, the density of the air, and the temperature of the air, and also other data like the runway size, runway width. It's gonna give us the takeoff speeds V1, V rotate, and V2. So we're gonna have the rotation speed and takeoff speeds V2 plus 15 knots. So we're gonna start climbing. We're gonna pitch the aircraft. We're gonna have a pitch attitude in the takeoff rotation like 9 degrees or less, and full takeoff thrust power setting. So we're gonna have a pitch attitude like this, and we're gonna start climbing. We're gonna have the seats also inserted. The seats which are standard instrument departure waypoints and fixes that include horizontal, vertical navigation fixes and altitude and airspeed constraints for the initial climb of the aircraft. Altitude and airspeed constraints, the seats. So we're gonna climb to the cruise level using the seats as other instrument departure waypoints and fixes, and also the airspeed constraints. Climb to the cruise level like 35, 36, 37, 38, 29, 30,000 feet above the sea level. We're gonna fly through some waypoints and also make some turns, and we're gonna start the descent, initiate the descent back to the elevation of the airport like 7 or 6,000 feet above the sea level. We're going to be aligned with the stars. The stars are the other terminal arrival waypoints and fixes for the terminal approach and landing of the aircraft. We're going to be aligned with the stars, and those stars are going to be aligned as with the runway heading, the magnetic north pole heading of the runway 14 of 136 degrees. We're going to be using also the Lszh localizer for that, the instrument landing system of the aircraft and the airport of the runway. We're going to use the runway 14 that transmits the radio frequency of the instrument landing system, the Lszh localizer for the horizontal alignment, again with the magnetic north pole heading of 136 degrees, and the vertical glide slope, the vertical, as you can see, angle of approach for the flight path of approach. So we're going to be aligned with both the localizer and the glide slope. The onboard elements of the aircraft receive the radio frequencies transmitted from the Lszh localizer of the runway. I'm going to use for takeoff and for landing. So we're going to be having the Lszh localizer, horizontal localizer, vertical glide slope, and the Lszh localizer crossbar display and primary flight display. We're going to tune the Lszh localizer frequency. We need to tune the frequency for each runway separately. We do this usually automatically, or we can do it manually from the radio management panel. As you can see here, we have the radio management panel, so we can tune the Lszh localizer if we need over here. The frequency, radio frequency receivers. Have also communication, VHF, satellite, ground proximity weather radar, transporter. You can see also the transporter here. The fuel flow to the engine, left and right engine, the rudder trim. So this is a radio management panel. We have also the fuel control. I will talk to you later. Left and right engine over here. So we're gonna have the complete flight plan or flight path for this aircraft. I'm gonna start showing you the flight management computer how we're gonna create the flight plan right now. So we're gonna be using 15 degrees. I'm gonna be using 25 or 30 degrees of flaps extended for approach and landing, as we're going to be approaching the Lszh localizer and the stars. We're going to have also 160, 170 knots, about 250 or 300 kilometers an hour for approach and landing of airspeed. So we're going to be having also the landing gear extended, the pitch altitude of 9 degrees or less, and you're going to see complete manual flight. So I'm going to start setting up the flight management computer. You can see here we have, as I told you, the mousepad screen here, the touch screen, so you can use the mousepad to control. So I'm having my own mousepad here to control the functions of the flight management computer and the screens and the input over here. As you can see, my own keyboard and the computer display. So you can see the setup for this. So I'm gonna use now the flight management computer. Input all the data. So we'll start with the screens here. I will set, as you can see, I'm moving the mouse pad, so you can see identity, position, performance, approach, annunciate status, navigation data, flight plans, load traffic control, load route, load flight plan, save flight plan over here. So I'm going in this display over here, in this view of the cockpit control quadrant. You can see the mouse pad. So we're gonna use this view over here for setting up the flight management computer of the Boeing 787. You see identity, Boeing 787-900 GNX engines, position over here, Iraq cycle position. We have the reference airport, Lszh, Zurich International Airport in Switzerland, so we can use the IRS alignment, the inertial reference system alignment. So we go in the performance. You see zero fuel weight plus fuel on board. We have the gross weight for takeoff. We're gonna use cruise altitude, cost index, the fuel freezing temperature, center of gravity, reserve fuel. So we start with the route, Lszh airport in Switzerland. Copy paste here. Again, departure, origin and destination. So we have the runway 14. clear over here. So we input the runway, so we use departure over here. We can use either runway 10, 14, 16, 28 or 32, so we can use other runways. So we're gonna select runway 14 and the seats, which are the standard instrument departure waypoints for the initial climb and airspeed and altitude constraint. We use the Zui to Alpha. We go again in the departure arrival. Now we're gonna set the arrival index. We can use VOM 16, 2834 over here, ILS 14 ILS 16, ILS 28 ILS 34 over here, GLS 14 localizer 28 localizer 34. So we're gonna use ILS 14 trans Amiki. So we're gonna use also Negria 1 Alpha for the stars as other terminal arrival waypoints and fixes. So we have the legs over here. We have the route, the origin with blue. So we're gonna use the legs over here. Cancel the discontinuity. So we're gonna start the first waypoint, the heading of the runway, one waypoint by another, the distance, nautical miles, climb to the cruise level, descent, approach and landing. So the route is not yet active, it's displayed with blue. We go over here. We have zero fuel weight, 322.7 thousand pounds, plus fuel on board 34,200 pounds, gross weight 357,000 pounds. We use 5% of reserve fuel, cruising altitude 25,300 feet, which is gonna have an impact on the consumption of fuel. 100%. The cost index of fuel freezing temperature 37 degrees, minus 37, actually below 0 in Celsius, and the cruising center of gravity. So we recirculate the fuel in flight, so we won't freeze. We press execute and it activates the waypoints of the route over here. So we have an active flight plan. You can see one waypoint by another waypoint over here. The first one 136 degrees, heading 2 nautical miles from the runway, threshold 250 knots, airspeed 1900 alpha above sea level. So we make a left turn here, 1 nautical mile, 250. Then we proceed 3 nautical miles, 6 nautical miles is the Zui, 301 knots, 6000 alpha, heading 052. Then we make a turn, Nigria 071, 26 nautical miles from Zui, 301 knots, flight level 22,200. Then we make a right turn over here, 12 nautical miles, 320 knots, 11,800. We descend for approach and landing. We make a right turn, 12 nautical miles from Negria. We have Amiki, heading 258, 6 nautical miles from Matif, 190 knots, 10,400 feet, 6 nautical miles from Matif. Then 9 nautical miles from Matif is Zui, 276 degrees, heading 9 nautical miles, 180,000, 7,000 alpha, Z8, Zurich 701, 6 nautical miles from Zui, 186,000 alpha. Then we make TRA 10 nautical miles, 185,000 alpha, CI 14 235, 6 nautical miles, 184,000 alpha. Then we make a left turn here to align with the runway, 5 nautical miles, 174,000 alpha, runway 14, approach and landing. So we use flaps 15 degrees, center of gravity trim 33%, 4.85 degrees, and the takeoff speed V1, we rotate V2. So this is all we need to know for the flight management computer. We have also other functions from the flight management computer over here. We have the navigation radio, hold, FMC, communication, progress, alternate, fix. So we're gonna use the legs over here. Go over here. I need to set up the autopilot over here, the airspeed guidance, as you can see. So you can see we have LNAV and VNAV now is active, the lateral navigation and vertical navigation of the aircraft. So we can use the airspeed here, whatever we like. So we turn off the flight director, we turn off the LNAV, we cannot use it, and the VNAV. So we have also the auto throttle left and right over here, arm and disarm. The autopilot disengage and autopilot engaged. So we're gonna set the airspeed for takeoff over here. We're gonna use the bank angle over here and heading. I'm gonna select the magnetic north pole heading of the runway, 136 degrees over here. Also the altitude, we're gonna cruise 35,000. You can use higher than that, but we're gonna cruise 35,300. Also we use the vertical speed flight path angle over here, so we can descend if we want. You will see the minus sign, or we can climb the other way, the aircraft. You're gonna see the plus sign. So this is a few things we need to do before setting up for takeoff over here. You can see also we have the flight management computer, the navigation data over here. So you can see the cruise, how we're gonna cruise in flight over here when we start the aircraft flying. As you can see, if we look closer, you're gonna see the flight plan. We have created the stars. Also the runway we use for takeoff over here. The taxiway, the terrain in front of us, how far above the terrain we're gonna be flying, the terrain elevation. So if we look forward, you see the taxiway runway, just like over here in the GPS. Also the terrain. So this is what it should be displayed from over here. From the displays also, if we look further away, like this, you can see more airports. You can see here is Germany, France, Switzerland. So we have also the plan here, this view, as you can see, even closer. So this is the flight one we have to fly, the runways, again, used for takeoff, map setting. So you're gonna see, now we're gonna be flying in a couple of minutes. So we have the map here. I'm gonna show you now the overhead panel. I'm gonna start the APU, the auxiliary power unit over here. Start, we have the left and right IDC, the great drive generator, left and right engine, 130 to 200 volts for 100 Hz frequency, primary flight control computers in the auto position, air data computer over here, flight control surfaces over here, all the systems I saw you, window sheet, hydraulics. Over here we turn off the hydraulics pumps, the left and right engine driving, primary in demand. You're gonna see what it displays. So we turn back on, and then to the auto position we have the electric and the rammer turbine over here for a standby. Also we have the cargo and APU fire, the recorders. We have the electronic engine control for the engine that control the fabrics. Also the auto start, left and right engine. We can dump some fuel. Let's select the nozzles to lose weight in flight. We have the fuel on board, left and right. The crossfeed valve, we can use it. We will feed either engine with either pump or either tank, and also balance the fuel between the left and right wing. So we can use the valves like this, as you can see, and the fuel booster pumps. Also we have the bleed air, the pressurizer from the left and right engine, the air conditioning, the cabin pressurization. In the manual we use the outflow valves for climb and for descent. In the auto we need to do nothing. We have also the wing and engine RDIs over here on auto position. So all the systems I just showed you in the overhead panel. We have also the lighting system. I'm gonna show you in a digital format. Then we're gonna make an engine start demonstration. We have a couple of minutes only. So you're gonna see now the digital format of all the systems over here. So you can see here we have the hydraulics, the APU is running, the oxygen, the liquid cooling. We have also the electric, as I show you in the overhead panel. So you can see the left and right generator contactor drive, 100 to 200 volts for 100 Hz frequency. alternate current, APU is running. Also the batteries, 31 volts and 28. We have two batteries. The hydraulics, where the hydraulic fluid goes, which system use it. The side-off valves, isolation valves, primary demand, left, right engine driving, the electric C1, C2. Also how much hydraulic pressure you have, 5100 psi, and the quantity of the hydraulic fluid over here. So we have also the fuel. You can see the left and right wing fuel tank over here, 11,000 pounds, and the center tank 11,000, total 33,800. We have the low and high pressure fuel valves, the left and the right engine, both open and feed both engines. The corrosive valve is off, but when we turn it on, you can feed either engine with either pump or either tank. The APU is fed from the left wing using the DC motor. Also here you can see the minimum fuel temperature, minus 37 degrees, below which the fuel will freeze. Also the fuel temperature for flight, minus 6 degrees. So we can see also the air pressurizer from the left and right engine from the APU. So we can use also the doors are closed, the cabin can be pressurized, the gear, pressure of tires and temperature of brakes, flight controls. Over here you use either left and right, climb, descent, rudder, deflections. So you can see also the train stabilizer. So this is the flight controls deflection displayed in the screen. So we have a couple more things. The FS display over here, maintenance, circuit breakers over here, also the checklist over here, normal, what we do before start, after start, before takeoff, after takeoff, descent, approach, landing. So we go back, we have communications also, so we turn off both engines right now. As you can see, fuel control to the off position. So you see APU, you can see both engines having off. So gonna see the outside view. You can hear the roar of the engines are going, slowing down. So you can see also the hydraulics are off because the engines went out. So we start the auto start over here very quickly. Both auto start to the on position. So you can see we have pressurizer from the APU is increasing above 20%. You can hear the roar from the engines. We only have pressurized air from the APU. We can let the fuel on right now. So both fuel control like this, both fuel run, and we see the auto start is kicking in. So it will take like a few seconds, 30 seconds for the auto start to start the engines. So we have 32%, now 35, 36, keep it increasing, all the data. So we have 51, all the yellow indications go off. So above 60% we have running engines, and we can go for takeoff. So we have running both engines. So flaps for takeoff over here, like 15 degrees, parking brakes off, advance the thrust levers, and we use the tiller to take the air traffic control clearance for takeoff. So we use full takeoff power over here, advance full takeoff, and we take off. So we press over here the yoke down until the takeoff speed is reached. So we have 80 knots, we have only rudder now. So we have 100 knots over here, 120 V1, We rotate slightly, 9 degrees. Use left rudder right now. So we have the takeoff, positive rate of climb, as you can see. So you can leave the hands off from the flight controls, no problem. It keeps flying, as you can see. So we have all the air data here. You can see the terrain with the yellow, green, yellow in front of you and around you. We have 1,900 feet, 2,000 feet above the ground, about 3,900, 2,400 above the ground, 4,000 above the sea. So we keep climbing over here. As you can see, the airspeed 109 knots, the wind direction and speed we climb with 4,000 feet per minute. Also the pitch altitude of the aircraft as we're climbing. Also you can see here the engines indication, also the terrain below you as you're climbing. You can see we are like you can see the red, you can see the green indication here is the terrain below us, like 3,000 feet. This is the aircraft symbol, so we're flying approximately 3,000 or 4,000 feet above the terrain. So we need to start the turn now. You can see the lakes, the Switzerland, Swiss Alps, and the airport. So we start with the turn of the aircraft to align with the flight plan over here. So we keep climbing. So I hope you like the view from the star sign, the galaxy, the crescent. Over here, beautiful view of the Switzerland, the Swiss Alps. We have the Germany also in this side and the France. We'll be flying over. So we're gonna be flying over some more nice views. As you can see, make change here, turn. So you can see all the air data over here. Also the head-up display. So the primary flight display, you can see the airspeed that we have. The stall speed over here with the yellow and the red indication below the airspeed. The rate climb, the trend we climb with 2,500 feet per minute. The bank angle right now. So this is the bank angle. So you can see we have to follow and fly through the waypoints over here. So we have the Zui, the Nigria now is the next waypoint, is 24 nautical miles, so we need to follow the Magenta line of the flight plan over here, as you can see. So make a right turn here, and we have a few more minutes to go back to the airport. So hope you like also the view from the outside again. So we have the galaxy view over here, the Switzerland, the lake, beautiful lake over here, the Germany, my homeland, the Bayern Munich in front of you, and the France. So we're gonna start the turn now. We're going back to the airport. Start turning. And we have like 10 more minutes left. We're going back to the airport. Climb to 20,000 feet over here. Also use some right rudder. So you can see how we turn over here. So we overflying the lake, the Germany, Bayern Munich over here, and the France in this side, the Italy this way, and the Switzerland. So this Boeing 787, about 21,500 feet, or more than 6,300 meters right now, the altitude as we overfly. So we need to align here with this side for going back to the airport. 32,000 feet, aligning also with the flight plan here, as you can see. So we have the frozen vapors also are now created. So we align here, leveling off. We need to increase the airspeed for going faster, as you're gonna see. So this is the aircraft here. Like we have a very beautiful view outside, as you can see. So this is the lakes. We need to level off here. The Germany behind us, the star sign over here, and the frozen vapors. We are about 33,800 feet. You can see the lake, beautiful lake, the Germany, the France. So we need to start the descent now, back to the airport. So we're gonna start the descending now, back to the airport. Idle thrust and start descent. Also use some speed brakes over here, as you can see. Speed brakes extended, and we need 6 more minutes to go back to the airport. So you can see the airport, we are overflying it already, as you can see. So use a little bit more thrust. So this is a beautiful view of the cockpit right now, as you can see. Hope you like it. As we flying over here. So we cross 17,000 feet over here. Keep descending. So we need to start the turn now. We have 4 more minutes. Keep descending, idle thrust. And start the turn for alignment with the runway. So we need to keep descending over here as we make the turn over here. Use a little bit left rudder, like this, left rudder, to take the turn a little bit faster. To keep descending. So this is the turn. Keep descending. And we need to align with the runway. We have 3 more minutes to reach the airport, as you can see. So we'll be using landing gear down as we descend, you can see. So we are aligned with the runway here. Need to align with the runway. For the approach, add some thrust over here. So we need to use some flaps also as we are approaching. Keep descending. Add some more flaps. And we have 2 more minutes for approach and landing. So we're going to be slowing down the aircraft. So here we are aligned with the runway. So we have some side wing, some wind gust over here. A bit more thrust. You can see the runway. You can see also we have the Lszh localizer here, the instrument landing system of the airport. So we have a lot of side wind to align the aircraft with over here. A lot of wind gusts and side wind, as you can see. So we use a little bit right and left rudder from time to time. Also use full flaps. So we're gonna be aligned here for the flare. So here is the flare of the aircraft, as you can see. Beautiful flare, touchdown, nose wheel down, beautiful, very beautiful alignment. So parking brakes and thrust reverse, full thrust